Just put it right there. Thanks. All right, so now this is the third thing of this section. All right, it's taking us like a week to do this section, but that's all right. I want you to learn how to do it. That's why I'm taking my time on each of these three topics. All right, the third topic. What was the first topic we did on this section? Find the what? The distance. What was the second one? We just went over it. Find the midpoint. Obviously, the third one is the slope. So the slope basically is this. It just tells you how steep a line is. Oops, forgot to do this. There we go. All right. So I got a line like this, and I got a line like this. Tell me, which one is the steeper line, the first one or the second one? The second one, obviously. It's a lot steeper. Everybody see that? So that means, watch this. If I did this, that's that one right there. If I compared how far up and down I went compared to how far across I went, everybody see that? Let's make that a different color. Okay? Everybody look at that. See that line right there? See the red one? It's a lot longer than the green one. Would you agree? All right? So the one that's going up and down is a lot longer than the one that's going across. That means it's pretty steep. Would you agree? What if I did this? What if I compared this one? This one's not as steep. So what if I compared this one to this one? Everybody see that one? Look, the red one's a lot longer than the green one. That means it's really, really steep. Okay, look at this one. The green one is longer than the red one. So this one's what? Not as steep. What if they were exactly the same, the green one and the red one? Then it would go up what? How many degrees? What if you went over exactly the same amount that you went up? How steep is that going to be? No, that's not 90. Here, watch this. This is not something I talked about in the other class, and it's really nothing that you absolutely need to know right now. But watch. Oops, that's not what I wanted. Let me grab this. I thought I grabbed it. Okay, copy it. All right, that should work now. There we go. Okay, and then let's do this. Let's make it red. And let's do this. Give me a second. Almost there. Let's do this one. Let's make this 90. There we go. All right. Now, both of these lines are exactly the same length. Okay? I just copied and pasted, and I just turned the other one up. All right? So, I just want you to think a little bit. What about that one right there? What if the up and down was the same exact as the one that's going across? What do you think? I don't even know if I should have done this. I probably went down a place I shouldn't have gone, but I thought a few of you would be able to figure this out. Any idea what that angle is? Yeah, but what number? Give me a number.
I would say 30.
If this is exactly the same as this? 90. Exactly. Well, it's not 90. Sorry. I was going to say something about 90, and you said 90, and I thought, yeah, that's right. Now watch this. Look, this and this are exactly the same, correct? All right, that's 90 degrees right there, okay? I'm talking about this angle right here, the angle that this white line is making to the ground. Yeah, no. I mean, it's true. All three would add up to, but say it. Somebody said it. 45 degrees, okay? So watch. If this and this were the same, then this angle right here, right, this would be the same as this angle up here. They'd be 45 degrees, all right? That's all I'm doing. That's not what we're doing in this section. We're not even going to talk about degrees or anything in this section. I just thought I would say it, and I wish I wouldn't have now. All right, so anyway, that would be 45 degrees. So let's do this. Let's forget about that. What if I took this line and I just tilted it like that? You know what? Let's do this. Let's copy this. Let's paste it, and then let's tilt it. Okay? And I'm just going to move this over. Going to move this over. Let's talk about this. Now, from left to right, like if I was going to climb up a mountain or go down a mountain, if I'm starting here all the way to the left, what would I be doing? I'd be going what? I'd be going up the mountain, wouldn't I? Would you agree with that? All right, so we say that this thing has a positive slope. Slope just means how steep the line is, okay? Positive means what direction is it going? Well, from left to right, it's going what? It's going up. What about left to right here? What's this line doing? It's going what? It's going down, right? So if I was at the top of it, starting at the left, I would be going down this mountain, wouldn't I? Going down the hill. And so what kind of slope do you think this has? Good. Negative slope. So that's kind of important to understand. Just by looking at it, you can see that that's positive and this is negative. Agreed? All right, that's enough of that. Let's move on to something else. Let's really get into what we're talking about today. I'm just going to draw a random line. Now, to find the actual slope of this, we want to find how steep it is. And what we're going to do is we're going to do a comparison. All right, hope everybody's watching. Justin, you watching? So what we're going to do is we're going to compare how far you go up and down. Whoops, I'll let go too early. How far you go up and down to how far you go across. Made that red one just a little bit too long. Make them meet. There we go. That's pretty good. All right, everybody see that on that? So what I'm going to do, in order to determine how steep this line is, all right, I make a comparison to how I pick any 2 points. I could have picked a point here and here. I could have picked a point here and here. I just picked the two end ones, okay? So I pick a point right here, and I picked a point right here, and I want to find out how steep that line is. So what I do is I compare the up and down to the across. Now, for those who say they remember this from your Algebra 1 days, which was last year, okay, what do we call the up and down? We call it the what? R, I. What is it? Nobody? The rise. Do you remember that? Yes. Okay, so we talk about this as being the rise. It goes up and down. Rise goes up and down. What is the thing that's going across? That's the run. So how do I find the slope? The slope is equal to the comparison between the rise and the run. When I compare two things, I make a fraction out of it. So the slope is equal to the rise over the run. Everybody's heard that before, haven't they? In a previous math class. You never heard rise over run? Is it really?
That's the first time I heard
You serious? At GCA? You never did rise over run?
it. Yeah, Algebra 2.
And you had Algebra 2? And you never did rise over run? You didn't have Algebra 2 then.
I took Algebra 2.
Not if you didn't do rise over run. You didn't have a real Algebra 2, because this is like an Algebra 1 topic. Right? This should just be a refresher from Algebra 1. But I'm teaching it as if you've never seen it before. So if you've never had it before, don't worry about it. Okay? I'm teaching it as if you've never seen it before, okay? But it is something that should have been taught in Algebra 1. Anyway, let's keep going. So the slope is the rise over the run. It's the comparison. I compare. How far up do I go compared to what? How far across I go. Everybody see that? All right, so that's the rise over the run. Very, very important topic. All right. By the way, we have a letter that represents the slope. It's kind of weird that they would pick this letter. Does anybody remember what it is? It's not Y. You'd think it'd be S, wouldn't you? Okay, it seems like it would make sense. If it was S for slope, it is M. Very good. So you do remember. Where did you take Algebra 1? Was it here? Did she come here last year? Okay. All right, good. So she taught you this stuff then. You did in 8th grade as well? Yeah, I mean, it's definitely something you probably could have had before Algebra 1. Absolutely. But again, it doesn't matter, okay? That's history. No big deal. We're learning it now, okay? So hopefully, except for Taj, because he's sleeping through this, he's going to say, no, I never heard this before, because he hadn't, because he's sleeping. All right? What's that? Yeah? Well, get your head up then. I'd rather your head up and your eyes up than your thumb up, okay? All right. So anyway, slope is the rise over run. that's super important for what we're going to do right now. Now, I'm going to do something that might freak you out a little bit. I'm going to do it anyway. All right, we got 2 points. I got a point here. We've done this twice already. We did this with distance. We did this with midpoint. If this is my first point, how do you think I'm going to label my first point? We did this with distance. What goes first? X and Y. But if this is my first point, that's my second point, how do I label this? Thank you. X1. Oops. If I can get this to write. Come on. Why isn't it writing? There we go. X1 what? Y1. If this is my second point, what am I going to label that? What? X always goes first. X always goes first. So this is my what? X2 and my what? Y2. It absolutely matters. It absolutely matters that X goes first. Okay? That's my first point. That's why I put 1s there. This is my second point. That's why I put 2s there. Now, this might mess you up a little bit. Don't worry about it. Okay? You're just going to have to worry about the end of this. All right? If you can understand this part, it's great. If you don't, it's not that big of a deal. All right? I want to find what this point is. And it's not X3, Y3. Okay? I want to write this in terms of X1 and X2 and Y1 and Y2. So where is this point right here? If I was on an X and Y axis, right, on a coordinate plane, where would this be? How far did I go over? I didn't go over X1 because X1's right here. How far in the X direction did I go over? I went over the same amount as this went over, didn't I? So how far did I go over to get to this? I went over how far? X2. I went over X2. So what's this point right here? It's X2. How far up and down is this point? It's not at Y2 because Y2 is way up here. What other point is in the same Y direction? This Y1. Very good. You got it. Okay? Now, if you didn't understand that, it's not that big of a deal. I'm not going to worry about it. All right? But that's where this point would be located. Okay, again, if you didn't get that, no biggie. All right? What I want to do is this. I want to find what is the distance of that red line right there, just the straight up and down. Okay, how far is it from here to here? Well, this is the Y, this point is Y2, this point is Y1. I did this in the other class, I'm going to do it for you guys. What if this point was, I don't know, something 7, all right? You went up 7 to get to here, and you went up, I don't know, 3 to get to here. What is the distance between 7 and 3? It's 4. What did you do? What math did you do to get 4? No, 7 minus 3 equals 4, not 7 minus something. You went 7 minus 3 equals what? 4. So the length of that would be 4, wouldn't it? But I don't really know that that's 7, and I don't know that that's 3. But I do know that the top of it is Y2. I know the bottom of it is Y1. So how do I find the rise? Not following me? Look, listen to me. If this was 7 and this was 3, how did I find the rise? How did I find the length? I subtracted. Okay, but I don't know that's 7 and I don't know that's 3. But I do know what? I do know this is Y2, and I know this point is at Y1. So how do I find the distance between Y? I subtract. Yes, you got it. Y2 minus Y1. Very good. With that same thought process, what do you think the run is? Well, let's do, why would you add? You subtracted to find the distance between here, so you do the same thing here, except you're using the x's instead of the y's. So where are you? You're at x2 here, so it's x2 minus x1. All right? Everybody with me? So now let's put it all together. To tell you the truth, in order to answer the problems on the homework, you don't have to know any of that stuff, all right? I'm just showing you where it came from. Listen. I'm just showing you where it came from. That's all I'm trying to do, all right? Yes? Well, you don't really need it. It's not being multiplied by anything, right? You don't really need a parentheses. So watch. Everybody watch. So the slope, I'll just write the word slope instead of put an M. I'll put an M later on, but right now I'll just write slope, is equal to what? The rise over the run. What did we say the rise was in terms of x's and y's? What is the rise? y2 minus y1. y2 minus y1. What did we say the run was? x2 minus x1. All right, that's the run. This is the rise. Everybody got it? And what did we say was the slope? It's the comparison. You're comparing the rise to the run. You're comparing y2 minus y1, which is the rise, to the run, x2 minus x1. This right here is what you need to memorize. If you didn't understand anything that I just did, it's fine. It's okay. Don't worry about it, all right? This right here is what you want to know, all right? It all came down to this. All the stuff that I did before was just showing you where this came from. Instead of me just throwing it out there and saying, here it is, learn it, this is how you use it. I kind of showed you, I tried anyway, I tried to show you where it came from, all right? So let's use this to do a couple problems, all right? And again, what are we doing? We're finding the steepness. How steep is the line? That's what you're doing when you find the slope of it, okay? You understand that? All right, let's write it down again. Just so, and I'm going to put an M instead of the word slope because we use M a lot when we deal with slope, all right? We're going to use it a lot later on, all right? So get used to the slope being the letter M. By the way, people don't even, like mathematicians, they can't even agree why we use the letter M, all right? Because I looked it up one time because somebody asked me. I never even thought about it, to tell you the truth. Then a student years ago, well, just a few years ago really, asked me, Mr. Hamrick, why do we use M for slope? Why don't we just use S? I'm like, that's a good question. Why don't we just use S? Why do we use the letter M? Well, I looked it up, and people don't even agree why we use the letter M. But they kind of lean towards, it might be like a Latin phrase or a Latin word that kind of means mountain, right? M. This is what some people think. So the way I like to remember it, is M stands for what? Mountain, which means it goes up at a slope, right? Does that make sense? All right. It doesn't exactly mean that, but that's how I like to think of it. So that's why I use the letter, or that's why, at least I think they use the letter M. It probably has something to do with that. All right, so what is the slope? It's what? y2 minus y1, and it's over x2 minus x1. Remember, the y is on top. It has to be on top. Don't put the x on top. Why is the y, W-H-Y, why is the y on top? Because it's the what? It's the rise. The rise goes up and down. Everybody see that? Up and down is the y-axis. The run goes across. Across is the what? The x-axis. So it's the rise over the run. Everybody good with that? All right, so now here, let me give you an example. Here's an example of what they're going to ask you to do. They're going to ask you to find the what? The slope. And they're going to give you 2 points. Just like they did with distance. Just like they did with midpoint. They're going to do the same thing with slope. Okay? And let me flip my page over. Find out what my 2 points are. Okay, find the slope. It'll say find the slope between these 2 points. And I'm just going to give you the 2 points. So it's 0, 2, and 4, negative 1. All right, so here we go. Let's find the slope. I'm going to put, m equals, I'm going to put a little fraction thing. Now, what do I do on the top? I got it right. No. Right, so that means I just subtract the y's. I subtract the y's. Now, here's something. I've always been writing y2 minus y1. If you wanted to, you could go y1 minus y2. But, listen, if you go y1 minus y2, you have to do what on the bottom? x1 minus x2. You have to. Everybody got it? You can get away with it on distance by switching the x1 and the x2. You can get away with it on midpoint, right? You're just adding the x's. On this one, you have to go in the right order. Okay, you could go y2 minus y1, but you'd have to go x2 minus x1. Again, you could go y1 minus y2, but you would have to go what? X1 minus x2. So let's do it the way that we wrote it, and we'll do it twice. I think we got a couple minutes here. Let's do it twice. So what's my y2? That would be -1. That's my second y. Agreed? And this is my what? My y1. That's my first y. So I'm going to go -1 minus what? 2. Now I'm going to do the same thing with my x's. I'm going to do the second x, and it has to be, if you go the second minus the first on the y's, you have to go the second x minus the first x. You got it? So -1 minus 2, what's the x going to be? 4 minus 0. And let's work it out. That's going to be what? -3 over 4. Is it simplified? Yeah, always reduce the fraction, and that's your answer. It's as easy as that. It's probably the easiest out of the three. Definitely easier than doing the distance formula, okay? And it's a little bit easier than doing the midpoint, because the midpoint you got to divide by 2, right? On this one, you just subtract, and then you put one number over the other. If you can simplify it, you need to simplify it. I just want to show you that it doesn't matter what order you subtract them in, as long as you subtract the top and the bottom in the same order. Do you hear what I said? I repeat that phrase over and over and over again. It doesn't matter what order you subtract them in, as long as you subtract them in the same order. So let's subtract them in a different order. Now, the y's have to be on top no matter what, okay? It has to be on top. Instead of going -1 minus 2, what could I have done?
2 plus 1.
2 minus -1. I know, but not everybody's going to understand that, okay? So what about the x's? What is the x? 0 minus what? 4. All right, what do you get? 2 minus -1 is the same as 2 plus 1, which is 3. 0 minus 4 is -4. Is this the same as this? Some of you might look at it and say, no, it's not. That's -3. That's a +3. But it doesn't matter, okay? If you wanted to, you could put the minus right in between them. It's the same exact thing. Everybody see that? All three of those things that are circled are the same exact answer. So can you subtract them in a different order? You can, as long as what? You subtract the top in the same order as you subtract the bottom. Okay, let's do one more, and I'll let you do this one. Okay? I'm just going to give it to you, and so again, you're finding the slope. So find the slope between or through, it depends what book, but between these 2 points, 1, -4, and 3, 2. You can't wait till this. Can you wait till this is over? I mean, if you can, that'd be great. If you can't, I understand, then you can go. But all right, everybody do this one. Okay, do this problem, come up with an answer. Taj, do this problem. So you're finding the slope. Anybody get an answer yet? Anybody want to volunteer? Nate, what'd you get? Why are you looking up there? Did you do it? Trying to think if it's right or not. Josh, what'd you get? What is it? 6 over 2? Okay, what did I say, though, at the end? Always simplify it. What is that? Okay. I'm getting like 4 or 5 different answers here. That's not a good sign. Is it? I'm not saying it's negative. I'm asking. All right. So what is it?
6 over 4.
6 over 4?
6 over 4.
It's definitely not 4.
Wouldn't it be 6 divided by 2 when it's 3? And then that would be 3 over what? That would be 3 over 5.
Let's do it. Let's subtract. Look, let's do the y's. Let's go y2 minus y1, okay? So I'm going to go 2 minus what? Negative 4. Okay, you know what's going to happen there in the next step, right? Let's do the x's now. Now, if I went 2 minus negative 4, I have to do what? 3 minus 1. Right? All right, let's do it. 2 minus negative. What's minus a negative? It's plus. What's 2 plus 4? 6 over what? 3 minus 1 is 2. Do I leave it like that? No. Always simplify your fractions. 6 over 2 is what? 3. What if I did it the other way? It should come out to the same thing, right? If I do it the other way, x1 or y1 minus y2 over x1 minus x2, it should come out to the same exact thing. Let's see if it does. Some of you guys are saying it's not, but let's see it. So let's do the y's first. So what do I got? Negative 4 what? Minus 2. Let's do the x's in the same order. If I went this minus this, I have to do what? 1 minus 3. What's negative 4 minus 2? Add the opposite. Negative 6 over what? What's 1 minus 3? It's not 2. It's negative 2. You guys watching? So what's negative over negative? Positive what? Do you get the same exact answer? Obviously you do. Okay? So you got to make sure that you do it in the right order. It's not that hard. I don't know. What did you say? Well, you tell me. You tell me if you got the right answer. Did you get the right answer? Zion, you asked me the question. Did I get the right answer? I said, what did you get? You said 3. Okay, what did I already written down? 3. No, this is the answer. I circled it. I wouldn't circle it if it wasn't the answer. All right. So here's your homework. Your homework is section 3-4C.
It's on the worksheet, right?
It is. It's on the lesson plan thing. But I'm writing it down anyway because a lot of you don't look at what I give you. Okay, put it right on there. Right there. Thank you. All right, there's your homework right there. Get it done. That's due tomorrow. Get it done.
Is this on YouTube?
Of course it is. It's always on YouTube.